In this video today, we're going to talk about linked lists, which are another way of storing sequential data. And side note, they're also frequently asked about during technical interviews. So if you're looking for an internship this summer, pay attention. So, one thing about linked lists that's different from arrays is that you can't index them. You can't ask for the third item in a linked list because all a linked list is one node that points to another node that points to another node. So say you want to get to the third node in a linked list, you have to go first node to second node to third node. So why would we do this when we can just build an array and grab the third node easily by saying array 3? Well, linked lists, you use less memory because with an array, when you make one, it allocates a set of memory for your array length. While with a linked list, you build your memory places as you go, as you add a new next node. So let's go ahead and start building our node class, which will then be the foundation of our linked list. So remember when we make a class, we just have that keyword class, and then out of convention, we're going to name this node. And then we open up our curly brackets and go inside. So what a node usually has is data, so we'll make a data property, and we'll, in our case, go ahead and make it a string right now. And then let's make a next property, which your next property will always point to a node, because that's the next node it's pointing to, or a null value. So this is a new thing that we just threw out there. This vertical line right here that went between the node and the null value means that our next value can be a node or a null value. So this is one vertical bar rather than two vertical bars that we use with expressions. And what this means is that you can just initialize that to either node or null. And this is important because with a linked list, the last item in the list will always point to null. Basically, that's how it says, hey, I'm the last one, there's nothing else I'm pointing to, and that's why we need to say null. So what is this null word? What does that mean if I assign something to null? That basically means build a space in memory for this object, but don't fill it with anything. So it is given a null value. If your computer goes to something in memory and nothing's there, then it can be like, okay, this is null. And when you assign something the value null, you're telling your computer that it's okay that you found nothing there. Great, so we have a node class, okay, what are we going to do with this node and what kind of linked list do we want to make? Well, one way that you may have kind of used linked lists in life that you didn't really realize was a scavenger hunt. You're going through the scavenger hunt and you're not really sure how long it's going to last or what's the next one, and the only way to get to the next clue is to go through the previous clue. Okay, so let's go ahead and start making our scavenger hunt. So we need to make a first clue. So we'll say clue 1 is a node and that equals new node. And then we're going to go ahead and initialize our data field, which is going to be the string that's our clue. So our first clue is going to be go fishing at the Carmichael Fish Bowl. Side note, if you ever get an email that has a link in it that asks for your username and password, do not fill it out or your email will be lost. Personal experience. Watch your emails. Okay. Now, for our next property, we don't have to worry about it right now because we're going to later initialize it to be our second clue. So let's go ahead and make our second clue. We'll say clue 2 is going to be node, and that equals new node. And our data property for this one is going to be our second clue, which is going to be browse for some cookies at Lenore. Because in Comp 110 right now, we're doing some web development, which involves cookies, so incorporate it into everyday life and make sure you're eating cookies. Once again, we don't need to initialize our next property for this, but we can go ahead and initialize our next property for our first clue because we now have our next clue. So we'll say clue1.next equals clue 2. Great. Now let's make our third clue. So same as previous, we'll say clue 3 is a node, which equals new node, and our data for this one is going to be get a bit of coffee at the meantime. Great, and then for now, we can also go ahead and initialize clue2.next equals clue 3. And then we have our one final clue. So we'll say clue 4 is a node, which equals new clue. And we're going to go ahead and say clue4.data equals filter a glass of water at the old well. Because we love using filter functions here in Comp 110, and seriously, we should be a little concerned about the quality of the water since so many people use that old well. Great, and then we'll go ahead and initialize our final clue3.next to be clue 4, And then remember, you do have to initialize all the properties of all of your nodes. So for clue 4, this is why we use that OR statement in our class. We're going to say clue4.next is null. Because remember, your last node in your linked list, by setting its next equal to null, is kind of giving a wave to the user being like, hey, I'm the last item in the list. Great, so we have our linked list. Now let's go on our scavenger hunt.
Alright, so now let's write a function that models us going through this scavenger hunt. So we want our function to go through each of our clues and print out the data of each clue, print out what each clue tells us to do. So let's implement that function. We'll say function scavenger hunt, and as a parameter, this function will take in a node, and we'll say that the type of that node is going to be node or null, because this function could either take in a linked list to go through, or the node that we pass it could be null. So then, because we want this function to just print out the clues, it won't return anything and the return type will be void. So inside this function, we'll want to put a while loop, and we'll say while the variable node does not equal null. So while node is not null, inside the while loop, we want to print out the data property of the node variable. So we'll just print node.data. And then after that, we'll say that node is assigned the value of node.next. So we have this variable node that we're keeping track of, and that's like the current node that we're on in the linked list. So we'll start out by passing in the function the first node in our linked list. It'll check if it's null, it won't be null, and it'll print out first clue, and then it'll assign that variable that node's next property, which will be the next node in the linked list, and then do that again until node is null, which means that we've reached the end of the linked list. Great, so let's test our function now. Outside the function, we can just say scavenger hunt and pass in clue 1. And if we save and run our file, we should see all of our scavenger hunt clues printed out. So we could also implement this function recursively. And recursive functions call themselves until they reach some base case. So in this case, our base case would be that we've reached the end of the linked list. And otherwise, we'll just want to call the same function with the node, the next node in the linked list until we get to that base case. So let's try and implement a recursive version of the scavenger hunt function. So we'll make a new function called recursive scavenger hunt. And the parameter will be the same. It's we'll call it node, and it'll be of type node or null. And just like the last function, the return type will also be void. So remember, when you're writing recursive functions, the first thing you usually do is set up your base case. So our base case in this example will be if the node that we're passed in is null, that means that we've reached the end of the linked list and we just want to return. So we'll just put the keyword return, and even though the return type of this function is void, that just means stop the function here. And if the node we're on is not null, that means we're on some clue to print out. So we'll want to print node.data. And then once we've printed out the current clue that we're on, we'll want to go to the next clue, and in this example we're doing it recursively. So we'll say recursive scavenger hunt, we'll call the function that we're inside, and pass in node.next. And so how this function will work, we'll pass it the first node in the linked list, it will check if it's null, it's not, so it'll print out the clue, and then call the same function with the next node in the linked list, which will check if it's null again and print out the clue, and it'll do that all the way until we pass in the next node of the last element in the linked list, which will be null, and we'll stop. It should do the same exact thing as our iterative example from before.